How's it going, guys? All right, we're on lesson 6.5, which is on solar eclipses. You're going to see a lot of stuff that's pretty comparable to that of lunar eclipses. It's roughly the same concept, but it's not exactly the same. And there's different circumstances that take place. We'll kind of go over those. So, what is a solar eclipse and how do they occur? So basically, just like a lunar eclipse, it's eclipse is just when a shadow is casted on a different body of matter. So in the case of a lunar eclipse, the Earth's shadow was casting, or the Earth was casting the shadow on the moon. That's a lunar eclipse. With the solar eclipse, it's just opposite. So the sun is shining and the moon is casting a shadow on the Earth. And while you think it might be a much smaller shadow because the moon is 400 times smaller than the sun, in reality, it's also 400 times farther away. So what that ends up doing is it makes them look roughly the same size, and the shadow ends up being much larger because the moon is a large celestial body within distance. So if you were to look at the sun and the moon up in the sky, you'd think they were about the same size. But because the sun is so far away, it looks roughly the same size. So there's different types of solar eclipse. We'll go over those. But any time that a lunar shadow is casted upon the Earth, we have a solar eclipse. And this doesn't happen incredibly often because of the offset tilt of the moon as it orbits the Earth. It does have a tilt, which keeps this, uh, from occurring oh so often. And then you have the axial tilt of the Earth. So these things lining up perfectly is actually pretty rare. And we'll go over that too. So there's 4 types of solar eclipses. The first one is a total solar eclipse. So this is when, like the image projected, this is when the moon is completely blocking the light from the sun, at least the direct light. So you might see that ring of fire, but you won't see the body of the sun, but you will see the indirect light creep behind from behind the moon. That's a total solar eclipse. This only is really visible in specific parts of the Earth. The moon is considerably smaller, but because of the size distance, if all bows correctly, they do line up versus the moon being smaller than the sun or the sun being smaller than the moon. So that is a total solar eclipse. These occur the most rarely out of the 4 different types of solar eclipses. You then have a partial solar eclipse. If you remember the penumbral and the umbra solar or lunar eclipses, remember we had partial, we had penumbral, and then we had a total solar eclipse or a lunar eclipse. It depends on which segment. In this case, the moon is in versus, remember which segment the moon was behind on the other side. This side is the same side as the sun. So this occurs during a new moon stage, whereas the lunar eclipses occur during a full moon stage, right? So instead of it being sun, Earth, moon during a full moon stage, it is sun, moon, Earth. So this occurs during a new moon phase. So still monthly, but depending upon the linear trajectory, where it's going to line up in the tilts, you get different positions where that moon will line up. So in some cases, the moon will line up directly in the umbra, and it'll keep all of this will experience the path of totality, which is where you see a total solar eclipse. If the moon lands within the penumbral, you will get a partial. If it's within both, it will get a partial. If you land strictly within the penumbral, you will get the partial solar eclipse as well. So the path of totality is aligned where the sun and the moon are completely lined up, and their distances managed to the point where the sun's direct light is completely blocking the sun's indirect light is creeped behind the moon, but all the direct light is completely blocked by the moon. Okay, so it really has to do a lot to these distances. These distances play into factor a great deal. So one specific area of Earth, because there's all these different factors, might experience a total solar eclipse every 400 years, let's say 200 or 400 years. That means me in this exact spot I'm sitting in, I might experience a total solar eclipse where it's this type of solar eclipse. I might experience that once every 400 years. But different parts of the Earth will experience a total solar eclipses during different times. So like Antarctica might get it here in a month, and then all of a sudden Australia's getting it, and it's not even a whole country that's going to experience it. It's actually just a brief part of it. So like it might cruise along northern Texas and Louisiana, but it'll never touch, Colorado and Arkansas. You see what I'm saying? So there's a set latitude that it's going to go across, and then there's the barrier where you can see it depending upon how high or low you are in the country. But every single place will only get to experience a total solar eclipse every 1 to 400 years. So it really just depends on where you are. I mean, if you want, you can go and chase these things around, because scientists, because they do understand these very predictable patterns of the sun and the moon and the Earth, they can predict where it's going to be. So you could go see a total solar eclipse 1 month in Australia, and then go see another one in Greenland the next month. And I'm just assuming those places, but they can't predict where they're going to be, but it's all dependent upon where you're at. So you're not going to experience us in Tulare, California. We're not going to experience this every month. It just doesn't work like that, because they're not as often. So you can kind of see what I'm talking about here. There's annual solar eclipses, and then there's total solar eclipse. A total solar eclipse is when they're lined up just perfectly, so that only indirect light is creeping behind. If you get this ring, this bright ring, this is the annual solar eclipse. These are the next two due dates in their path to totality. This is where you would see them. So we are not going to see one in October 14th, 2023. As you can see, Tulare, California is roughly in the Central Valley, towards the middle of California. We're not going to be within that path of totality. We may see a partial lunar eclipse. I'm not incredibly sure of that, but we might see a partial lunar eclipse because of our position, but we won't see a annual solar eclipse. You would have to be within this path of totality in order to see it. If you are on this side of the country, you may see a total solar eclipse. Remember, the reason why it curves like this is because the Earth is on that 23.5 degree tilt. So the Earth is spinning in these kind of directions. So if you are on this side of the country, let's say you're in New York, you may experience a total solar eclipse on April 8th, 2024. But if you are, hanging out in West Virginia, you may only experience a partial solar eclipse. Hope that makes sense. Just think about, when we learned about in Unit 2, frame of reference. So a car seems a lot faster when you're looking at it from a perpendicular position. But if you were looking at it from behind, it doesn't seem as fast. So it's one of those things that your frame of reference really can change the way you see certain things. So this is the forecast on future solar eclipses. It's the concepts are the same with the partial, annual, and hybrid. A hybrid is just a combination of total and annual. So like one side might have the ring, whereas the other side does not. That's basically all it is. In an annual, you get the ring. Partial, it's basically you'll see the shadow of the moon on the sun, but you won't see the entire sun. And then a total solar eclipse is when all but the indirect light is blocked. Very, very similar to the lunar eclipse as far as the shadow casting and the like frequency of when this stuff actually occurs and how often it occurs. So that is total solar eclipses or solar eclipses. Look over that stuff, and I encourage you to go on the internet, see what you might see in the future, when the next solar eclipse is, and this stuff doesn't happen so often, so it's very easy to just breeze past these things. It'll come around again, but it's not as often as you think. So if you get the opportunity to see one of these, don't look at it in like directly because you'll mess up your eyes. But there's a lot of different ways you can look at these things and experience them, and they're pretty cool. So, all right, guys, that's all I got for you today. I will see you next time.